So guys, we are going to start solving quadratic equations, and in order to do that I want to remind you and review how to simplify square roots. So all we're doing in this video is reviewing how to simplify square roots. Remember that a square root is also called a radical sign, and the number underneath the radical is called the radicand. I don't know if you've seen that word before. That's radicand. So if you see that ever, that's just the number underneath the square root. All right, so when we simplify square roots, mathematicians have just come to the conclusion or to agree upon that we need two things. We want to make sure no radicand, so no number underneath the square root, has a perfect square factor other than 1. And we also want to make sure that there are no radicals left in the denominator, so no radicals in the bottom part of a fraction. All right, so perfect squares. What do I mean by perfect squares? You might want to write these down the side of your notes, but those are the numbers that when I take the square root of them, I get a whole number. So for example, square root of 1 equals 1. Square root of 4 is equal to 2. Square root of 9 is 3. And where am I getting these numbers? Well, I know that 3 squared is equal to 9, so that's how I knew the square root of 9 is 3. So you can generate this list anytime, and this will help you know what your perfect squares are. I'm going to write them all here just so we can refer back to them in case we need them. So the thing I need you to know is that I need you to figure out how to generate these numbers. And I would like for you to know them all the way up to 100, at least. Okay, because the square root of 100 is 10. Now, some other ones that are common that you might see are the square root of 121, that's 11. 144, square root of 144 is 12. 169 is 13. 196 is 14. And then 225 is 15. So these might pop up from time to time. Anything higher than that you probably won't see in the ones that we're doing by hand at least. Okay, so let's continue. So if we have square roots, we have two properties that we can use. So we have the product property and the quotient property, and these are really nice. It allows us to simplify square roots depending on how it looks. All right, so we can either, if two things are multiplied underneath the square root, we can pull it apart, or if they're two separate square roots, we can put them together. And the same thing goes for when we have the quotient property. So if I have two things that are divided underneath the square root, I can separate them. I can pull them apart and to make two square roots. Or if I have two separate square roots divided, I can put them together to make a single fraction underneath the square root. So why would we want to do that? Well, let's look at some examples. So in this first one, the square root of 18, if you look back at your perfect squares, the square root of 18 is not on there. However, I know that I can pull that apart into two separate square roots that are multiplied together. So think about that. If I try to come up with two numbers that are that multiply to give me 18, and I want one of those to be in my perfect square list, well, I'm thinking of the square root of 9, and then this would have to be the square root of 2. Now the square root of 9 is on my list, but square root of 2 is not. So even though they're both not on my list, I know that the square root of 9 is just a plain old 3. That's the whole number 3. Now the square root of 2 is not on the list, so that's going to stay the square root of 2. And this is what we consider simplified, because there are no longer any perfect squares I can factor 2 from. I can't pull 2 apart. So this would be my final simplified answer. All right, let's look at the next one. So square root of 2, square root of 10, neither of those are in our perfect square list. And if I multiply those together, I can multiply that so that it's just 2 times 10. What's 2 times 10? That's just square root of 20. Well, square root of 20 is not on my list either. However, I can pull square root of 20 apart. So think about what two numbers multiply to give you 20, but I want one of those to be on my list. Now, 2 and 10, those multiply to give you 20, but neither of those were in our perfect square list. So I'm thinking, what about 4 and 5? 4 is on my perfect square list, and it's okay that 5 is not. So the square root of 4 is simply 2, and then the square root of 5 just stays square root of 5. So this is my final answer. All right, so if you're having trouble figuring out how to pull it apart, then let's say you're trying to pull apart the square root of 45. Then go through your list and just start dividing things. So obviously you're not going to try to do 45 divided by 100. All right, so try something a little bit smaller. So you might try to do 45 divided by 36. See if that comes out to be a number. No, that doesn't work. That comes out to be a decimal. Then you can try 45 divided by 25. Does that come out to be a whole number? No, that doesn't either. So you can just keep going through your list until you get one that works. So if you do that, you can see that 45 divided by 9 gives you 5. So that means we can pull 45 apart with those two numbers. So these are my two numbers I can put underneath the square roots. So I'm going to have square root of 9 times square root of 5. Those are the two numbers that multiply to give me 45. And I know 9 is on my list, so I can simplify that to be plain old 3. And then square root of 5 stays square root of 5. So that is the simplified version of square root of 45. And then in this other number 4 example, again, square root of 5 and square root of 20, those are not on my square root list. But if I multiply those together, I get square root of 100. That one's on my list, so the square root of 100 is simply 10. And I don't have to do anything else to that. So now we've used the product property on all of those. Let's look at some with the quotient property. So in this first one, I can't do 5 divided by 9. That's a fraction. That'll be just a decimal, so that doesn't help me. So if I split these up, I'm going to pull these apart. And so now I know that the square root of 9 is simply 3, and then the square root of 5 stays the square root of 5. So what I've done here is, because I pulled them apart, I was able to get rid of the square root in the denominator. Remember, that's our other criteria. Now we also have to check, can I pull this one apart? So that's what you always have to ask yourself. Can I pull that apart? And no, I can't pull 5 apart. It's just 5 and 1, so that doesn't pull apart to be anything. So this is my final answer. So I can use that same idea on this one. Again, 5 divided by 49, that's a decimal, so I can't do anything there. So I'm going to pull these apart. And notice that 49 is on my square root list. So the square root of 49 is simply 7. The square root of 5 stays the square root of 5. And again, we know that we can't pull apart 5, square root of 5, so that's going to stay that way. So notice that in my final answer, I don't have a square root in the denominator, and I can't pull apart the square root in the numerator. All right, look at this one, number 7. Right, these are already separated, and notice I can't do the square root of 40 or the square root of 5. Those are not on my perfect square list. However, if I were to put them together, so put them all underneath the same square root, I can do 40 divided by 5. That comes out to be just plain old 8. So I can do 40 divided by 5 is 8, and now I've just got the square root of 8. So I don't have a denominator anymore. But now we need to check, can I pull this apart? Okay, so can we pull it apart? Yes. Think about two square roots that multiply to give you 8. One of them has to be a perfect square. So that's going to be 4 and 2. So the square root of 4 is just 2, and then the square root of 2 stays the square root of 2. And that would be our final answer for number 7 there. All right, so the last thing I need to talk to you about with simplifying square roots is rationalizing the denominator. All right, it sounds kind of intimidating, but basically what happens if you don't get perfect squares in your denominator? What do you do then? Well, here's where we're going to multiply the entire fraction by any form of 1. Remember, when I say form of 1, if I multiply something by 1, if I do 5 times 1, that stays 5, right? I didn't change that value. If I do negative 7 times 1, that stays negative 7. But we can write, if I do 3 divided by 3, that's the same thing as 1. So I could do 5 times 3 divided by 3, and that's still like doing 5 times 1. Okay? So all of those things mean we're not going to change the value. We're just going to be creative in what we're multiplying by 1 in. So here's how we do that. In this first example, number 8, I can't do the square root of 7, square root of 3. Those are not on my list. And I can't divide them. That's a decimal. So what I'm going to do is multiply by the same thing in top and bottom, because that's a form of 1. And I want to choose something so that I do get a perfect square in the denominator. So if I were to multiply square root of 3 by another square root of 3, what would I get? Well, the square root of 3 times square root of 3 is square root of 9. That's on my perfect square list. 7 times 3, that's just square root of 21. I don't care about the numerator. I really just care about the denominator. I want that to be a perfect square. So I can always get that by multiplying by that same thing in the denominator. So I chose square root of 3 because square root of 3 was in the denominator. So now I've got something like before. I can simplify the denominators. So I have square root of 21 in the numerator, and then square root of 9, that's just plain old 3. So I've gotten rid of the square root in the denominator, and then I can't pull apart square root of 21. So this is my final answer. Let's do another one. So if I look at this one, number 9, what should I multiply by? Well, what's in the denominator? Square root of 8. So I'm going to multiply top and bottom by square root of 8. All right, so let's do that. So in the numerator, I'm going to get square root of 40. And in the denominator, I'm going to get square root of 64. Okay, so why is that good? Well, square root of 64 is on my list. So I'm going to keep square root of 40 in my numerator for now. And then the square root of 64 is simply 8. Now, can we pull apart square root of 40? Yes, we can pull that apart, so we have to do that. Also, let's pause here for a minute. Square root of 40 divided by 8, that is not the same as the one we did in number 7. All right, 8 is not underneath the square root, so I can't just do 40 divided by 8 is 5. All right, so don't think that. The 8 is not underneath the square root, and the 40 is underneath the square root. All right, so I'm going to pull apart square root of 40. So I need to think what two numbers multiply to give me 40, and one of them has to be on my square root list. So I'm thinking 4 times 10, because 4 is on my square root list. So this is going to become 2. Square root of 10 stays square root of 10. So now instead of square root of 40 in the numerator, I'm going to have 2 root 10, and in my denominator we still have 8. Okay, so this part got replaced with that pull apart version. Now, normally we would think, okay, we're done. We pulled it apart. I'm going to ask you to do one more thing. This 2 divided by 8, this is not underneath the square root. And I always harp on you to reduce your fractions. So 2 over 8 can reduce to 1 over 4. So I'm going to want you to reduce that fraction if you can. So you can write it as 1 square root of 10 over 4, or you can just write that as square root of 10 over 4, right? Because 1 times square root of 10 is just the same thing. So either one of these would be our final answer. So you're going to get some more practice on simplifying square roots, and then we'll do more of solving.